So today we will continue our discussion of the estimation of nonlinear models using regression analysis. So remember, kind of like the big picture, we've been talking about estimation of nonlinear models. And, we talk about the main characteristics of nonlinear models. And we said that nonlinear models are models, but basically intuitively, they show curvature and kind of, mathematically. So we say that the marginal effects are not constant. Okay, and then we said that we will be talking about the estimation of two types of nonlinear models. The first one is the quadratic model, which we talked about in the previous two classes. And the other type of models are going to be what we call, log models with logs. I'm going to rewrite this thing. Models with logs. It's, logarithmic models. Okay, another way to call them. So these are logarithmic models. So again, both type of models, the quadratic model and the model with logarithms, are models that can be used to estimate nonlinear relationships between a dependent variable y and a set of explanatory variables. So let's start to talk about like these models with logs, log models. And we will be talking about three types of models. So log models. Let me move up a little bit. So the first one is what are called log-log models. And these are models with we have both the dependent variable and the explanatory variable has been transformed before estimation. That's one way to think about it. You have your dependent variable and then you take the log, and that's what you're going to be using for regression analysis. So it's called log-log model because basically we have the log of y and also the log of x. Okay. The second type of models that we'll be talking about is what are called log-level models. Okay. So it's called log-level models because we will have as dependent variable the log of y, but as explanatory variable, we will have the original variable. And the original variable is calling like level. So we have the log of y and level for x. And the third type of model that we will discuss have to do, the third model is the level log model. In this model, we just have y, the original variable, without being transformed, and the log of x. So it's called level log because we have level of y and the log of x. Okay, so we'll go model by model. And today, probably we're only going to be focusing on the log level model. We're going to be talking about what are the shapes, nonlinear type of relationships that you can estimate with the log-log model. How do we interpret? How we can make predictions with this model, and then we'll look at this an example on how we go about using this model in the context of a specific data set. Okay, so let's look at the log-log model. So graphically, I'm going to write first the equation. This is a model where we have both the log of y and also the log of x. Yeah. And the type of relationships that we can estimate are as follows. So we have these models where we have a curve that is decreasing at an increasing rate if that beta 1 coefficient is less than 0. We could use this model when the relationship between y and x is increasing at a decreasing rate. And now the type of relationships is when the relationship between y and x is increasing at an increasing rate, and that happens when I think that I touched something. That happens when beta 1 is higher than 0. And of course, we also can estimate models where there is a linear relationship between y and x. So if beta 1 is equal to 0, we just have like a flat line. Okay, and also when beta 1 is equal to 1, the relationship between y and x is equal. When beta 1 is equal to 1, there is a linear relationship between y and x. Okay, so as you can see, this model is kind of flexible. So you can see all the shapes. You don't need to really memorize this type of shapes. Usually when you are doing analysis and you are trying to decide if it's a good idea or not to use a log model, you can always look online or go back to the notes, look in a book, and this is the type of relationships that you can estimate using a log model. Okay, so it's very flexible. So let's look at, so what are the advantages of using this model? Let me add some pages. So what are the advantages? Advantages of the log model. The first one is this is a model that is very popular in economics. And also in business, because of the interpretation of the coefficients. Because those betas that the beta that we estimate, the beta related to the explanatory variable, is actually the elasticity, because the coefficients are elasticities. And if you have taken economic classes, you know that economists really like elasticities. And the second reason is, they are very flexible. As I showed you above, this log model allows you to model like a wide variety of relationships between y and x, increasing or decreasing relationships where the curvature is changing. Okay, so let's look at the interpretations. Interpreting the results. Interpretations. So let me write again the model. So it's a log model. We have log of y and logs of x. Okay, so we know that beta naught is the intercept, but it does not have a very meaningful interpretation. So, we could say that beta naught is the average value of the log of y when the log of x is equal to 0. But I mean, if we were to interpret it that way, that's correct, but it's not very meaningful. Okay, so in generally beta naught, it does not have a very meaningful interpretation. It has an interpretation, but it's just, it doesn't tell us that much. I always say that, I think that there are very few people that's able to think in terms of logs, and I'm not one of those people. And generally, again, it's very hard to think in terms of log. On the other hand, the beta 1, it does have a very useful interpretation, and is the elasticity. Okay, so if we were in class, I would ask you, okay, so remember, I mean, what is elasticity? Well, so remember that elasticity basically tells you that a 1% increase in x changes y by beta 1%. So that's the way that we interpret that beta 1 coefficient. The beta 1 coefficient is elasticity, and here I'm saying changes, and I say changes because, if it's positive, you would say that 1% increase in x increases y by beta 1%. If the sign of beta 1 is negative, you have to say that 1% increase in x decreases y by beta 1%. Okay? So be careful about that. I mean, I write changes here because it could refer to an increase or decrease depending on the specific sign of beta 1. The other thing that we need to know about log models, so remember, if we just look at the model that way, I mean, yes, we are able to interpret beta 1. It's a very useful interpretation. It gives us the value of the elasticity, which is, very easy to understand. But you see, if we were estimating a model and our objective is prediction, again, we estimate the model and then we predict what's the value, what's the prediction. We're not interested in predicting what is the log of y. What we're interested in predicting is what's the value of y. Okay? So, in order for us to do predictions in terms of the original dependent variable, we need to make some additional assumptions. So, predictions of y with log models. So, in order for us to be able to move forward with the predictions, we need to make certain assumptions regarding the error. So we're going to be assuming that it's normally distributed with mean 0 and standard deviation sigma squared. Now, that's not a very strong assumption. It happens a lot of times. It's actually quite common that the errors happen to be normal. Now, there are some cases where they are not normal, but it's a very common assumption because in reality, it's common to find that the errors are normally distributed. Okay, so if the errors happen to be normally distributed, then the predicted value of y is going to be exp to the standard. Remember that the standard error of the regression is squared divided by 2 times exp, and this is the predicted value of the log of y. Now, what's that exp? Is the same e, is a constant. So we have this constant to the standard error of the regression squared divided by 2 times e to the log of y hat. Okay, so remember this e, and I forgot to mention that previously. I should have mentioned that e is a constant, which is equal to 2.7182. And if you are using Excel or any software, the way to write it is usually called exp, and that's why I wrote it that way. Okay, it's the same as saying e to the whatever is inside that function. So remember that, so this is the formula to be used, and I was trying to define what is each of the terms. So that's the formula to be used. So remember sigma hat, that's the standard error of the regression. Which we had used in the past. Okay, and we know where to find it in the results. And log of y hat is basically what we do is the predicted value of our model estimated using the log of y. Well, so since here I've only considered one explanatory variable, that should be, okay? But remember that more generally, actually we could have more explanatory variables. But for now, leave it there. So that's basically the predicted value of y. Now, something that I think I forgot to mention previously, I know that we've been calling these models with logs, but I never really defined what type of log are we using. So you should be aware that what we call log here in most of economic textbooks or econometric textbooks is actually the natural log, is the natural logarithm which is sometimes called ln, or the logarithm with base e. Okay, so for the calculations, make sure that you have that in mind, and also, when we have a lab, in Excel, the function for the natural log is actually ln. Okay, so have that in mind, but for our examples, I'll be using log, but when I call log, basically that refers to the natural logarithm to be consistent with the notation that we have in the textbook. Okay, so that's what I have for you today. So remember, we have we started to talk about log models, which allow us to model nonlinear relationships. There are three types of log models that are popular in economics: the log-log model, the log level, and the level log. So today we talk about the log-log model, which is a model where we have both the dependent and the explanatory variable are in logs. It's a very flexible model, and I show you the different shapes that we can estimate. This model has the advantages that the coefficient related to the explanatory variable are actually the elasticities. So you estimate the model, and then you get the elasticity. And I know that you have taken a lot of classes and a lot of examples. You are always asked to interpret elasticities, to calculate the elasticities. Where here, actually, I've shown you today how is that we can go about estimating these elasticities if you have data on the dependent variable and the explanatory variable. And the other thing that we learned is you see a lot of times we're interested in also making predictions. So to make predictions, we need to make the additional assumption that the error term is normally distributed If we make that assumption, then we have a formula for the estimation of the value of the dependent variable using the results of a model where we have used the log of the dependent variable.